Hello, welcome back. Now we're going to work on the next theme. By now, you should have watched the thematic revision video on diversity, cycles, and system. Now this one is on energy. So we are going to the primary 6 topics now, and after energy, the next video will be on interactions. So as before, I'll be using the questions from the P6 mid-year exam, the MCQ section, mainly for our revision purposes. And I will always encourage you to read up the particular textbook and the chapter related. And in this video, it would be on energy at P6. Read up first before you attempt the questions and reading and watching this video. Do also have a piece of paper with you, and a pencil or pen, so you can attempt the questions. Pause the video, attempt the questions, try to answer it before you play out the explanation. So let's get started. Okay, now let's go to the energy questions for this. Let's go to the life science section first. There are 3 questions for life science. So I'd like you to read the question partly first, because it's quite a long question, the whole page. So actually many of the students in my class here got this question wrong. That is like really many. Question 11. So apparently there's some misunderstanding in how you interpreted the information or the table or the picture. So I'll let you try one more time. I'm going to show the question. Alright, I hope you have attempted it now and already, and I'm going to go through this with you. Now Ali wants to find out how light affects the rate of photosynthesis. So if this is the aim, that means that the light, right, whether it is amount of light or presence of light here, so that will be the change variable. And how do we measure the effect of this? In this question, Ali measures it is in terms of the amount of oxygen collected. So if we recap the formula for photosynthesis, you have a gas. What's that gas? What else is needed? What are the 2 conditions on the arrow? The other one is? And what are the 2 important products that we get from the process of photosynthesis? And the gas is? And the last thing, yes, that's right, food. Or some of you write down sugar or glucose, which is fine. Now, so he measured the amount of oxygen inside the beaker using an oxygen sensor and recorded the observations in the table below. So let's try to understand the picture. There's a lamp, glass cover, which means light can definitely pass through this, no problem. And there's water. So we have the ingredients for this, right? We have light. There are leaves here. It's a plant, so there's chlorophyll. There's water. Alright, and it's surrounded by air, so I would definitely assume there's some carbon dioxide in the air. So definitely there's no issue with the oxygen production. There's no issue with having photosynthesis happening if there is light. So if you look at the table, in the first 2 minutes, right, the lamp was switched off. So there was no light happening. And what about the light in the environment? Is there light in the environment? No, there isn't, because this experiment was conducted in a dark room. And in science, as you know, in our science question, dark room means the absence of light. No light. Okay? Which of the following statements explain his observations in the table? So let's before you can even go on to this, so try to understand the rest of the information in the table. Now, lamp was switched on, and we observe this, right? Okay, the number of oxygen bubbles started to increase. So here it actually decreased, right, from 2 to 1, all right, and now it started to increase. Oh, from 1 to 5, 5 to 9 also increased, 9 to 10 is an increase but a slightly less increase, 10 to 11. Okay, finally, no more increase. So if you were to represent this part on a graph, how will it look like? For example, here is a plus 4, here is a plus 1, and here is plus 0, no more increase. Let us try to understand this on a graph, right? So if we draw a graph and talk about in terms of the minutes, right? So let's start off with first, second, third, fourth, fifth, 6, 7, 8. Okay. So let's see how it looks like on the graph. So clearly on this axis, what we have here will be time in terms of minutes. So this axis here will be the oxygen level. Alright, I'm not sure what is the units used, but it's oxygen. And we have some numbers there, right? Up to 11. So let's try 0. So 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, and 11. So let's see, we need the third, fourth. So 1, 2, 3, and 4. At the third minute, it was at 5 units. So third unit here, right? This is the one. At the ninth, then at the fourth minute, it was at 9. 6, 7, 8, 9. Then at the 5th minute, it was at 10. So 10 is here. Then at the 11th minute, so at the 6th minute, it was at 11. 6th minute, it was at 11. Then 7 and 8, it was at 11. So the graph, right, and let's check earlier on, at the 2nd minute, it was at 1. So the increase at first was very steep. And if you start from here, it actually went down from 2 to 1. There's a very steep increase. Okay, this part was a plus 4. Now here is still an increase. I'm going to replace it with a different colored pen. So here is now still an increase. It's still going up, but you notice the graph is now less steep. So the rate of increase has decreased. The rate of increase has decreased until here at this point, flatten. Here, no increase. This part here represents less increase. So the rate of increase has decreased. Let me write it down, okay? Rate of increase. Rate of photosynthesis has decreased here. This part, the rate of photosynthesis was very high because more bubbles were created in the same unit of time. In 1 minute, 4 bubbles. In 1 minute, 4 bubbles. Here, 1 minute, only 1 bubble. Here, 1 minute, only increased by 1 bubble. Okay? So, if you look at this, right, which of it is true? Photosynthesis started in the first 2 minutes, that is false, because first 2 minutes there was no light. So anything with A is wrong. Wrong. Okay? Now I need to look at B. There was no photosynthesis in the first 2 minutes. This is correct. Okay, but we know that there's B here, there's B, so B is definitely correct. Now you need to check for the either C and D. Let's take a look at this. The oxygen in the beaker in the first, okay, both have C. So no point looking at C, right? So we only look at D. The rate of photosynthesis slowed down before becoming constant. So the rate started to slow down. So again, as you can see here, the rate was increasing a lot. Right? The increase was by 4 bubbles, increased by another 4. Here the increase was less. So the rate of increase has dropped. The rate of photosynthesis has slowed down before becoming constant. Constant means here, see, no increase is your constant. Constant equals to no increase. So this graph helps you to see, I hope, what all these numbers mean. It helps you to see the rate of increase at this point has started to decrease, right? Increasing less and less until it stopped increasing. So D is actually true. If D is true, right answer here is 3 for question 11. Right answer is 3. Alright, so for the many of you who got this wrong, I hope this helped you to understand this. Because those who got it wrong, most of you choose 1. You didn't understand the idea that the rate of photosynthesis slowed down. Okay. Now let's take a look at the next question. Let's try question 12. Pause and do this. I'm sure you can solve this in a matter of seconds. Excess food, right? We talk about food is being sugar, right? So the food is being used by the plant for life processes such as photosynthesis, respiration, for growing, growing new leaves, for all kinds of purposes, and growing new roots. But there will be excess food left, and excess food will be stored as starch. So this question was very well done, question 12. Alright, everybody got question 12 correct. Okay, good job. Let's go to question 13 now. Pause and try this, alright? You don't need this, you just need to try it out first. What is W, X, Y, and Z? Okay. If you haven't pause it now and try. If not, I'm going to start going through this. The diagram shows a part of a plant that is placed under strong light. Again, we have light. Alright, so definitely you're talking about photosynthesis one more time. And we talk about substances moving. So the arrows represent the direction of substances moving. What is moving upwards? Right, typically we will understand this to be the water coming up from the roots. Through the water carrying tubes in the stem and into all parts of the plant. Alright? And we will understand the arrow moving out from the leaves. The leaves make something that travels in the plant. And what is that? And that will be food. Okay? Food made in the leaves, alright, travels out to all parts of the plant. So W would be food that is made. So W will be food, and X would be water. So what is happening during photosynthesis? What is given out during photosynthesis? The gas would be oxygen is given out, and carbon dioxide is needed. Right? Carbon dioxide is needed. So let's recap. This is a formula. Carbon dioxide is needed for photosynthesis to happen, and you give out oxygen and food, which is your sugar. Let's take a look. W. Okay, so let me just check my zoom. Give me a moment. Okay, much better. So W is food. Let's check. W is food, sugar. Yes, yes, yes. X is water. Oh, got the answer. Now let's double check. Y is oxygen and Z is carbon dioxide. So question 13, was it a question that was well done by you guys? Not bad. Everybody got this right. Okay, good job. Okay, now let's go on to the next energy question, but this time it's on our physical science energy question, and that would be question 26. Now, understand this part first before I go down to the rest of the question. Pause the video, please. Oh, this one. 16 students got this wrong. Okay, 21 got it correct. Let's take a look. The toy car below was released. Release always means you are not pushing it. It's like letting go. Okay, release. Let's let go. Right? At point X. So it moved, or rather it rolled down the slope. It passed point Y and keep on rolling, slowing down before stopping at point Z. Which of the following correctly states the forms of energy present at X and Y? So the first part of the question, the forms of energy present at X and Y. So that is one question. And the second part of the question is the energy conversion. Second part represents energy conversion from X to Y. So there are two parts to the question. Forms of energy at X and at Y. Let's do the first part in red first. This one. So what's the form of energy at X? It's a car, there's no mention of spring or anything. So, and it was released, so it was here for a while before the person let go. So at X, it definitely has gravitational potential energy. So X definitely here, these two. So at Y, it was moving down, right? So what forms of energy were present? Okay, present, very important word. So at this point, the car, right, is it still above the ground? Yes, so there is still PE, there's still gravitational potential energy. Is this car here moving? Yes, it is moving. So it will have KE. So these two forms of energy are there. If you understand this, you'll be able to understand this. That number 3 is the answer for question 26. Now those who got it wrong, you choose 1. Why? You were not alert that this question is asking you for the form of energy. You were thinking in terms of energy conversion. Oh, the GPE here converts to the KE here. That is correct for energy conversion. But if you're talking about form of energy, at this point in time, there are two forms of energy there present in the toy car at point Y. The energy conversion part is on this side of the question. Okay? So let's double check, right? So energy conversion from point X is here, GPE, comes to point Y, here is KE. Just these two. Okay, of course, this will be the main form of conversion, potential to kinetic, and there'll be other minor conversion along the way, like the sound when the wheels are rolling on the ramp, as well as the heat generated when the two surfaces are in contact. This will be energy conversion. So you notice that for answer 1 and 3 is very similar, heat, sound, kinetic, and potential. The thing that got you guys wrong is this part, that you didn't understand the demand of the question here. So please understand this is about form of energy, it is not about energy conversion. Okay? Now let's take a look at the next question. This one was quite well done. So how do you talk about energy conversion? There are only two of you got this wrong, so these 2 students, please take note. So a ball was placed in front of a compressed spring, then release, let go, again is release, right? And the ball rolled to the right. So here it was not moving at first. So if it's compressed, therefore there must be a lot of elastic potential energy stored in this compressed spring. And when it's released, the ball starts to roll and hit the wall. So along the way, the EPE must have converted into kinetic energy. Of course, plus either minor form like sound and heat. When it hit the wall, alright, definitely there will be sound energy, and there's contact, right? There will be heat energy. Of course, you can also argue there should be heat energy and sound here, but if it's not given, it means that it's considered the minor one and it's just being ignored in the options. So in this case here, the potential energy is converted into kinetic energy, and then of course there will be sound and heat energy when it hits the wall. Alright, so this will be the best answer in this question. Now, next one. Last one. This question has a lot of things to interpret, picture and graph and all that. And despite that, most of you still managed to get it right. Not bad. 5 of you got it wrong, but the rest got it correct. Huh? So let's take a look and see this. Pause, understand this situation first. Okay, so when the ball was here at first, notice the black arrow means the path of the ball as it moves upwards after leaving the hand. The white arrow shows path of the ball as it falls downwards after reaching the highest point. So point A, just as the ball left the hand, so it's no longer touching the hand, right? Just as the ball left the hand. So just true, just leaving that, just left the hand. This is where it stops for a while at the highest point before it starts to fall, and just before the ball returns to the hand. So the ball hasn't touched the hand. At point C and A, the ball and the hand are not touching each other. Okay, this one just left, this one just before it hits the hand. Now, other than arrows, there are also this solid line and dotted line to understand. So the solid line represents the potential energy, and the dotted line represents kinetic energy. So, at which point is there the most potential energy? Of course, at the highest point. There's the maximum potential energy here. Right, at the start, it was at the lowest point. At the end, it was the lowest point. So here should be the minimum potential energy and minimum potential energy. Now let's see whether is this enough to get us the answer. Just using potential energy. Because we're supposed to find out which of the following shows the potential energy and the kinetic energy of the ball at different points. So I'm thinking at point A, it should be minimum. At point C is minimum PE. And at point B, which is here, is at the highest point, maximum PE. Let's take a look. So I think the graph should look like this for the solid line potential energy. Let's see. This is the only one. Alright, this is the only one. At point A, starting point, lowest, go to the highest point at point B before falling down again. Now, let's double check also. The ball is slowing down, right? As it reaches point B, this is the slowest, this is the point where the ball stops. So at point B, this is the point whereby the KE equals to 0. No more kinetic energy because it stops moving. So I should say point B is whereby the KE, dotted line represents KE. KE is at 0. That's true. And when the ball just left the hand, that's when it is the fastest. Along the way, the KE also convert to other forms, not just PE, but also convert to things like heat energy as it moves through the air. That's why when it moves back to C, it's no longer as fast as before, less KE compared to at the beginning when it just left the hand. So therefore answer is 4, which you can get just you looking at the PE line, the PE line of the graph. Okay, that's the revision for energy. We talk about life sciences like photosynthesis. We talk about physical sciences like energy conversion, forms of energy, and we also talk about mainly these two. Okay, and we, of course, this main idea about the difference between form of energy and energy conversion. All right, take care. I'll see you in the last video, which will be on interactions, on forces. Bye.